In this lesson, we will look at how motion can be modeled using motion graphs. Before, you learned about distance and displacement, where distance is how far an object travels from its starting position, and displacement is how far an object travels and in which direction. Distance includes the entire path an object travels, while displacement only includes the straight line from the starting point to the stopping point. In today's lesson, we will look at three types of motion graphs. In all three graphs, time will be on the x-axis. The y-axis will change based on the type of graph. The three types are distance versus time or distance time graphs with distance on the y-axis, displacement versus time or displacement time graphs with displacement on the y-axis, and velocity versus time or velocity time graphs with velocity on the y-axis. Distance versus time graphs show how far an object has traveled over time. They are used to show speed. So here we have a dog walking from his house to a tree that is 5 meters away. Since he is starting at his house, we will set the house as the starting point by marking it as 0 meters on the y-axis. The dog walks 1 meter in 1 second, then stops for 2 seconds to smell a mailbox. Then he runs the remaining 4 meters in 1 second. On the graph, you will see three distinct motions: a section with a low slope, a section with no slope, and a section with a high slope. In physics, these tell you something. The low slope occurred when he was moving slowly. The flat horizontal line shows when he was stopped, and the line with the higher slope indicates that he was moving fast. So lower slope lines on the graph mean the motion is slower. A higher slope means the motion is faster, and lines with no slope mean the object is stopped. But what if the dog returns home? This is going to add a fourth section to our graph. Since this is a distance time graph, the direction of the motion doesn't matter. So if he jogs the 5 meters home in 3 seconds, the line just continues upward with a medium slope, indicating medium speed. This doesn't seem to show what really happened. It looks like the dog never went home. A more detailed graph is a displacement time graph. It includes the distance and direction of an object's motion over time. Displacement time graphs represent velocity. Let's consider the dog again. He walks 1 meter in 1 second, then stops for 2 seconds to smell a mailbox. Then he runs the remaining 4 meters in 1 second. Finally, he returns home by jogging 5 meters in 3 seconds. On the graph, you can still see the slope of the line in 4 distinct sections, showing you how fast the dog is moving. The main difference is going to happen when he returns home. Now the line moves downward and has a negative slope. This is because displacement time graphs also show the direction of travel. The line shows that he's moving towards his starting point, which was his house, which we marked as 0 on the y-axis. So for both distance time and displacement time graphs, the slope of the line shows how fast the object is moving. In each example, I broke the dog's motion into sections where his pace was constant. But what if the object is not moving with constant speed or velocity? What if the dog is getting faster and faster? Well, that means he'll be covering more and more distance for each second. So this will result in a curved line where the line starts with a low slope and gets higher. But what if the dog is getting slower? Well, that means he'll be covering less and less distance per second. This will result in a curved line where the slope starts higher and gets lower. By this point, you may not have learned a lot about the mathematics of curved lines, so it's easier to view acceleration on a different graph. Velocity time graphs use lines to show acceleration. The y-axis marks the velocity of the object. This means the graph shows you how fast the object is moving over time, instead of showing you how far the object is moving. On a velocity versus time graph, a flat horizontal line doesn't mean the object is stopped. It means the velocity is constant, so there's no acceleration. On this graph, line C is the lowest on the y-axis. The object is moving with a constant velocity of, say, 2 meters per second. Line B is higher on the y-axis and indicates that the object is moving with a constant velocity of 4 meters per second. Line A is the highest on the y-axis and shows the object is moving at a constant velocity because the line is flat, and it's at 6 meters per second. Different from previous graphs, a position of 0 on the y-axis of a velocity time graph does not mean that the object is at its starting point. If I had line D here on the bottom, It means that the object has constant velocity because it's a flat line, but it also shows that the velocity is 0 meters per second. But since it's at 0 on the y-axis, it doesn't mean that it's back at its starting point. It means it has a constant velocity of 0 meters per second, so it is stopped. But this y-axis indicates velocity, not position. On a velocity versus time graph, a sloped line means that the velocity is changing. So since a change in velocity is called acceleration, a sloped line on a velocity time graph means an object is accelerating. Again, the higher the slope, the faster the acceleration. A velocity time graph of a drag racer might have a high slope because drag racing cars are made to really reach a high velocity in a short time. A velocity time graph of me doing a 100-meter dash might have a lower slope because I've not practiced, so it will take more time for me to increase my velocity. If the line slopes downward, that means the velocity of the object is getting lower over time, or that the object is changing direction. A steep downward slope would occur if the drag racer slams on brakes at the end of the race and comes to a really quick stop. His velocity decreases quickly, so the slope is high, but moving downward because it is the acceleration is going down. A lower downward slope might occur when I slow down to a jog, then a walk, then a stop after reaching the end of my 100-meter track. My velocity decreased slowly, so the slope is lower. Showing a change in direction on a velocity versus time graph will be covered in a future physics course. So let's review. We have learned that distance versus time graphs show speed and do not indicate which way the object is moving. They simply show how far an object moves over time. Displacement time graphs show velocity and let you know how far an object moves in a certain direction over time relative to where you started. Both distance time and displacement time graphs will have a low slope when the object is moving slowly, a high slope when the object is moving quickly, and no slope when the object is stopped. For these graphs, a curved line indicates acceleration. Velocity time graphs were the third type we looked at. They let you know the velocity of an object over time and show you whether an object is accelerating. On a velocity time graph, a flat line with no slope indicates that the object has constant velocity. The faster the velocity, the higher up on the y-axis the line will be. A line with a slope indicates acceleration. A low slope shows the object is accelerating slowly, like if you push the gas in your car just a little bit. A line with a high slope shows that an object is accelerating quickly, like if you put the pedal to the metal. But don't do that. Drive safe. If the slope points down, the object is usually slowing down. Thank you so much.